Docker ML Studio is designed to streamline the entire ML lifecycle. Our Docker extension lets users effortlessly create, train, and deploy models very easily. We create a Docker extension with the ability to make deep learning models without the necessity of programming. All the code runs on Docker containers, and the data is shared through Docker volumes, allowing us to combine datasets and models on the same computer. Our user-friendly interface paves the way for designing neural networks without the need for coding expertise. With just a few clicks, you can deploy your models, eliminating the hassle of traditional deployments. So let's start with the demo.
Okay, so let's start with the application. In order to launch the application, we need to click on the button of Get Started. This button will launch our studio where we can see 4 sections. And the first section is for datasets, model building, experiments, and deployed. But at the moment, we don't have any dataset or model. So the first thing that we must do is create a new dataset. So click on the section of dataset, and this section will show a form with all the information that we need to provide to the extension to create a new dataset. And the first field that we need to provide to the application is the name of the dataset. And in this case, it's very important to use the same name that we use for the folder name that contains our dataset. So in this case, we're gonna play with the flowers dataset. The flowers dataset is a image dataset. And again, it's very important to say that at the moment we only work with image dataset. In the future, we plan to enable the other 2 types of datasets, but for the moment we only want to work with image dataset. And the next field that we need to provide is the description. In this case, this is the flowers dataset from Kaggle. And finally, we upload the dataset, and for upload the dataset we need to give the tar file with the dataset. So we select the tar file, and then we click on the next button. And finally, we have a very brief summary of our dataset. In this case, we can provide what will be the evaluation speed of our dataset, and very important, we need to provide, or we need to set for what type of experiment we are going to use this dataset. In this case, this dataset will be for a multi-class classification, so we select the multi-class classification and then save our dataset or create our data. Click on the button of create dataset. The next step is create a model. In this case, we're going to use our model builder, that is a very friendly user interface to create neural networks using only drag and drop. Our dataset that we're going to use is an image dataset, so we need a convolutional network. However, we provide to the user with vision model pre-training. In this case, we only have the ResNet layer, that is a ResNet architecture pre-training. But as you can know, the ResNet has 1000 classes, so we need to reduce the number of classes in our prediction. So we add a linear layer. In this linear layer, we need to provide the input size, that is 1000, and an output size that in this case we are going to use an output size of 256. And then we connect both layers, and then we are going to add a new layer that in this case will be an activation layer. Also, we're going to add a dropout layer, and this dropout layer, this has a probability by default of 50%. And finally, we add our last linear layer. In this layer, we have an input size of 256 and an output size of 5, that is the number of classes that are present in our dataset. And then we click on the save model button, and we provide the name of our models. In this case, I'm going to call this model ResNet 5, and in the description we provide a very brief description. In this case, this is only a ResNet architecture for 5 classes, and then we save the model. So we are ready to launch an experiment. So we click on the experiment section, and this will show the experiment form to create a new training process. In this case, we need to provide a name for our experiment. I'm going to call it flowers1, and we select our dataset, that is flower, and the model that we're going to use, that is ResNet 5. Then we choose a learning rate, that will be more or less 0.1. and then we select the optimizer. In this case, I am going to use the add-on optimizer and our loss function that will be cross entropy. In order to make a experiment for test, I'm going to only train for one epoch. We can use GPU. However, in this device, I don't have GPU for Docker, so I will uncheck this option of use GPU, and then I will launch the experiment. And then we are ready to deploy our model. To deploy our model, we click on the deploy section. In this case, we need to provide the deploy name. That is very important because this will be the name of our model in TorchServe. In this case, we call it FlowersNet, and then we choose our experiment. In this case, we are going to select Flowers 1, and then we provide the infrared port. In this case, is the 8080, and then we click on the deploy model. As we can see, we have here our model deployed. And to check that all is okay, we're going to try to connect up with our model. We're going to use the REST API. So with help of the cure command, we check our model. Okay. And here we have the prediction.